He's quiet, but anybody else, who do you think invented the transformer? And a transformer is a beautiful device that even nowadays people don't appreciate. Any clue? I get a, Fortune magazine carried some article with some of the scientific writers says, oh, you take Tesla invented a transformer and AC and so on. He didn't. It was some guy named Gilbert in Germany who invented the transformer. Yeah, the Gilbert in Germany, 50 years after the invention of the transformer, made it 50 kilowatt, water cooled, oil cooled, or whatever. That's just engineering. It has nothing to do with the concept. Well, let's go and say who did it. Okay. You heard of this guy? Faraday. What Faraday invented? He invented a concept of electromagnetic induction. For years, people knew you put a current, and Ørsted invented when you put a wire, and you put a DC current through it, you generate a DC field, and if you have a magnetic needle, it'll just point in the right direction. So you use the magnet needle to orient north, south, whatever. And the people for years tried to create magnetic field to establish a permanent current in the winding. And even Faraday in 1831 tried to do that and failed for quite a while. And story goes like one day he just had an assistant and he had very sensitive instruments, and these instruments were galvanometer making milliamps of the current and so on. But it so happened until that day he would flip a switch and go in a room where there was a sensitive galvanometer to see the current, and never saw it. Until one day he told his assistant to turn on a switch, and he was in a room and the galvanometer said, and just during that switch needle moved and moved back and forth. It says you need a changing electromagnetic field, and that was invention of a transformer. And what is the beauty of a transformer, even nowadays, that the people don't realize it? There are two things. One, that was immediately obvious with the Faraday's invention of it, and that is this. The transformer has the two windings. And what I said, remember these two windings are two inductances, okay? Large inductances, but they're not, they don't have a DC in it. They're AC inductances. And when you put here current in this dot, I1, what happens? There is a dot connection in the other winding. Current comes out of the dot, not into the dot. So the beauty of a transformer is it doesn't store energy. It actually, if you're on a perfect transformer with a 1-to-1 ratio, you have a square wave current, and the same square wave current shows up on the output instantaneously. Okay? No storage. Fantastic. That's number one property of it. Number two is galvanic property, isolates the primary and secondary side. And number three property is you can't have a transformer like this. This is so-called ideal transformer. The real transformer is made of magnetic material. And that means if you put a voltage here and you measure the current, you make a very little current because this inductance will be huge. Oh, Bernie Sanders said huge, right? So this huge, and what is this inductance? That is what we call magnetizing inductance. That is large because there is no gap, and it takes for whatever voltage, because this inductance, it could be, in a good ferromagnetic material like silicon steel and so on. This could be, Henry or so. So you have a milliamp of the current going here. And what is this milliamp of current? This current on input generates a flux in the core. So changing voltage here generates a changing current here, changing current generates a changing flux in the core. And guess what? Changing flux in the core induces a voltage on a next other winding which is not electrically connected to it. That's the beauty of a transformer. And you know what it is? Does this change? in magnitude, depending on how much current. Suppose I just dramatically show, yeah, oh, you want to put 10 times bigger current, okay, you'll get 10 times bigger current. Transformer never saturates on current. They tell you lies, and a lot of people have a total misunderstanding about transformers. A transformer will saturate. It never saturates because it's designed on a voltage support, not the current. So, so if this is a current I1 and current I2, you can pass the unlimited current. Of course you won't, because what happens? We put 10 times more current. Wires are not sized for it, so they'll melt. Okay, so there's a limitation there, but it's not related to. Sorry. It's not related to the fundamental concept that it saturates with it. So therefore, okay, so therefore, here we have the transformer. So, and I just get to one aspect of a transformer, which is 3. Transformer has to have galvanic isolation, but it's not enough. He is not storing energy, and you see in that flyback what I showed you, there is only one inductor. It's easy to split inductor in 2 windings, and you get isolation, meaning galvanic isolation. But it is a 2-winding storage inductor. It is not a transformer, and that's bad news. Okay, and so, but the other thing, which is here, this is in the days of Tesla, we only talk about 60 hertz. And that's why we are in an exciting period. Thank you very much. See, there are always computer experts around, you know, young kids. All right. Okay. What is at 60 hertz? You have a huge you have huge silicon steel for 100 kilowatt. This will be half, you know, this big. It'll be like a car. Okay, at 60 hertz. You know what? Now you have Tesla induction motor, which operates at 1.5 kilohertz. And 150 kilowatts or 200 kilowatts is this big and this in a cross section. Because it is only 50 hertz to 1.5 kilohertz, it's 30 times bigger in frequency, right? So that's what Tesla told Edison at the time, and say, DC is dull and boring. AC has an exciting thing. You can increase frequency to whatever you want, okay? And shrink the size, shrink the material cost, etc. And we are not even close doing that, okay? You know, because we don't know, you know, I'm telling you now, I'm working on my concept now, we'll see later in the Ken presentation, to make a battery charger. You know, they talk about superchargers and all these things that, to charge 20 kilowatt or 60 kilowatt hour batteries for 20 minutes in a car. But it's the size of the car. And it costs $100,000, and it's every 300 miles every which way you go. But the technology is here. But all we need to do is go from 1.5 kilohertz on that induction motor. Hey, if you can make induction motor at 1.5 kilohertz this small at 200 kilowatts, shouldn't we be able to make the charger, which is that much, at the 200 kilowatts? Because we are not doing it right. We are just doing it wrong. Okay. Yes. And so therefore, that's the. I think I'll just finish this part, so you got the lecture on completed. This is original 2 converter.